Jai Jagannath. So, welcome to lecture number 2 of chapter 24. So, in the last class, I was discussing about the capacitor, but in the last class, I had taken only one single conductor. So, what is the problem? I had told by taking the single conductor, the capacitance value will decrease, and that means to get to get a capacitance, to get a small value of capacitance, we require large space. So that was the first disadvantage. And the second disadvantage is that the energy is not bounded, because we are taking the conductor, we are taking a single conductor, and that electric field extends to the infinity. So energy is stored in the medium, so which is extended to the infinity. So to avoid that, we have to take special arrangement. That special arrangement is nothing but two conducting surface. So we will take, instead of one conductor, here we will take two conducting surface separated by very thin layer of insulating medium. Insulating medium is called also dielectric medium. So it will form a capacitor, so which store electrical energy by producing electric stress in the dielectric, and here energy is bounded within the two plates. So let us take an example comparing the one conductor with two conductor. Okay, suppose this is a thin spherical shell. Okay, so this is a thin spherical shell, only single conductor. This is single conductor, not two. So this is thin spherical shell, that is a conductor. So let us say the radius of this A conductor is A. So what is the potential? Potential, on the surface it is KQ by R. So let this A sphere is charged by maximum charge. Let us say, take an example, maximum charge of 100 coulomb. Let us say this A conductor can store maximum 100 coulomb charge. Corresponding to this maximum 100 coulomb charge, the maximum potential is equal to, say, 200 volt. Just I am taking an example. Okay. So now what we'll do, instead of this one conductor, I will take another conductor B. Okay. Suppose this is the A conductor. Initially we had taken. Surrounding to this A conductor, I will take another spherical shell, that is B. Okay, so what was the radius of this A sphere? It is A. And what is the radius of B sphere? Let us say it is R dash. So this is the radius of the second metallic surface sphere, that is R dash. So now we have to find what is the potential at A point. So initially the potential at A point is equal to KQ by R, and the maximum potential is 200 volt. The maximum charge can store by this metallic sphere is equal to 100 coulomb. Now we will find what is the potential of A due to this sphere as well as this sphere. So if the charge on this A sphere is given Q, then what will happen? So a negative charge will induce on the inner surface of the outer sphere. So that inner charge is equal to minus Q. And since this B conductor is electrically neutral, so what will happen? The total charge of B is 0. But here minus Q charge is induced on the inner surface of the B sphere. So definitely in the outer surface of B sphere will induce a charge of plus Q. So that this plus Q and this minus Q will be 0. So total B is electrically neutral. Okay, because we are giving only charge to A sphere. Now we will find what is the potential at A point. So potential at A point is equal to potential due to own charge, that is KQ by R, plus potential due to negative charge. Okay, so negative charge is on the sphere B, and you know, for a thin spherical shell, the potential or any conducting surface, the potential at surface is equal to potential at the internal point. Now this point is internal point for this B sphere. So here the potential at internal point is the same as potential on the surface. So what is the potential on the surface due to minus q charge? That is K minus q divided by, and what is the radius of the B sphere? It is r dash plus. So there is also plus q charge surrounding to the B. So due to this plus q, that is the outer charge, we will find a potential at A point. So what is that formula? K charge is q divided by, from center to the outer surface distance is what? So here inner radius is r dash. Inner radius is r dash. But outer radius is slightly more than r dash. So this is the total potential. Now the potential on this A conductor is now VA dash. So that is equal to, let us say this KQ by R. Initially KQ by R was what? 200 volt. Now I will put here 200 volt. So here plus into minus. Minus this KQ by R dash is definitely less than KQ by R, because R dash is greater than R. If R dash is greater than R, then KQ by R dash is smaller than KQ by R. So this magnitude is less than 200 volt. Let us say I am taking for an example, let us say 140 volt. Plus, this is what? KQ by R dash plus del R. That means if we will compare this value with respect to this value, then here this value will be slightly less than this value, because your denominator is more than this. So here let us say this voltage is equal to, just take an example, let us say, okay, this is, let us say, minus 40, and this is it is less than that of 40, let us say this is 20. So what is the net potential now on the A surface? So it is 180 volt. Now see, if we will take a single conductor A, the maximum potential is 200 volt and maximum charge can store 100 coulomb. So now by introducing a second plate, what will happen? The potential at A surface will decrease. So that decrease means we know the maximum potential can be 200 volt. Here potential is reduced to 180 volt. So that implies the charge, we can add charge more to increase the potential from 180 volt to the maximum 200 volt. So we can add extra charge. So that means charge carrying capacity of this arrangement now increased. So initially it was storing 100 coulomb. So with the maximum voltage 200 volt. But now by introducing the second plate, what will happen? The voltage is decreased to 180 volt. So we can go up to what? 200 volt, because this is the maximum voltage. So to go from 180 volt to 200 volt, charge carrying capacity, we can add more. That is charge carrying capacity. Charge carrying capacity means what? Capacitance. So capacitance will increase. So this is the principle of a capacitor. That means in a single conductor, the maximum voltage was 200, maximum charge was 100. By introducing a second plate nearer to the first plate, the potential of A now decreased to 180 volt. So we can go from 180 volt to 200 volt. So if we will increase the voltage, we can add extra charge. So here the charge carrying capacity of this arrangement will increase. That means capacitance will increase. Now another factor is there. If I will make earth connection to this second sphere. Suppose I will connect this second sphere to the earth. What will happen? So this plus q charge will go to earth. This plus q charge will go to earth. That means there is no positive charge here. there is no positive charge here because it is connected to earth. So if it is connected to earth, what will happen to the potential of A? So potential of A, now it is, let us say, V A double dash is equal to potential due to A, that is KQ by R, plus potential due to this negative charge, that is K into minus Q by R dash. And here this outer surface charge plus Q is already gone to earth. So now you see what is the KQ by R value? 200 minus this KQ by R dash is equal to what? 40. So what is the net potential? So net potential is now 160 volt. So in a single conductor, the maximum voltage was 200 volt. By introducing second plate without connection of earth, the voltage become 180 volt. Now if we will connect the earth, the potential again decreases from 180 to 160. So that means we can increase this potential from 160 to maximum 200. So in that way we can add more charge. We can add more charge comparing to the second case. So that is why it is a common question in every exam, why in a capacitor second plate is connected to earth. So what is your answer? To increase the capacitance, we can connect the second plate to the earth. Okay, so we may write this statement: the second plate of second plate of capacitor is always connected to earth to increase its capacity or capacitance. Okay, so this is the very important statement. Always the second plate of a capacitor is connected to the earth to increase its capacitance. So I have explained this in this figure. So now you see, so for the capacitor we need two plates. So here two plates are taken to be spherical plate. So these two plates may be also taken as a parallel plate. Let us say this is A plate, this is B plate. So these two plates are parallel and they are separated by a dielectric medium whose distance of separation is very less. So that is D, and here there is dielectric medium. So this is also called which capacitor? Parallel capacitor. This is which capacitor? Spherical capacitor, because two metallic surfaces are of spherical in nature. Now see, this is so instead of metallic spherical conductor, if I will take a rectangular plate, I will take two rectangular plates. So this is first plate, this is second plate. So they are separated by what distance? D distance. What is the area of plate? Area of plate is equal to A. So this figure is similar to this. So here I have drawn this line is indicating this is a plate, square plate or rectangular plate. Okay, so the second plate is always connected to earth. Remember, if you will take, this is a parallel plate capacitor, this is plus Q and this is your minus Q. If there is no earth connection, you have to assume it is already connected to the earth. So this is the advantage of using the to increase the capacitance, we always connected to the earth, to second plate. Okay, so now you see what is the advantage of this. So here advantage of so I can write advantage of using two plates for a capacitor. First advantage is that capacitance value increases, we have proved. Second point, that is the charge carrying capacity will increase. Second point, you see, within positive plate to negative plate there is a dielectric. So if it is air, it is called air capacitor. If the dielectric is glass, it is called glass capacitor. So you see, inside this two plate there is dielectric medium, and in between two plates there is an electric field. And due to this electric field, energy will be stored in between this. Why? Because you know, I have already proved in the Gauss law. Suppose this is a positive plate, this is a negative plate. In between positive and negative plate, there is an electric field. So what is the electric field of this? So electric field intensity in between two plates is equal to sigma by epsilon naught. Okay, it is already proved. And in the outside point, what is the electric field? Electric field is equal to 0. Why? If this is positive plate, for positive plate, electric field is away. For the negative plate, electric field is towards. So these two values are equal and opposite. So electric field intensity outside to this two conductor is equal to 0. Only electric field is present in between two plates. And since there is electric field, so there is electrical energy. So energy is stored within the two plates. That means energy stored is bounded between two plates. Bounded between two plates. But what? But in case of one plate, the energy is energy is bounded from plate to infinity. So there is no limit, there is no fixed area where energy is stored. But in this case, energy is stored within a fixed boundary. So that is the capacitance. Now see, how can you charge the two plates? How can you charge the capacitor? Suppose this is A plate, this is B plate. So now, so I am not taking A because the A indicates the area of the plate. Anyway, so this is M plate, this is N plate. So what I will do, I will connect a cell. So I will connect a cell or battery to these two plates. So this is positive plate means this M is positive charged. And this is negative plate means this is your negative charge. So this is in this way we can charge these two plates of the capacitor. Now question comes, what is the value of capacitance? What is the value of capacitance? In general, if the charge on this surface is Q, here charge is equal to minus Q, then and potential difference between these two plates is V, then we can say capacitance between two plates is equal to Q by V. What is V? V is nothing but potential difference between positive and negative plate. Okay. In case of one conductor, in case of one conductor, we had also written as C is equal to Q by V. But in that case, this V is what? It is a potential difference between that conductor and earth, because we are taking earth as the zero potential. I think it is clear. The unit is the same, that is coulomb per volt, that is joule. So now we will discuss dielectric. In a capacitor. What is the purpose of dielectric and what is the role of dielectric in a capacitor? So dielectric is nothing but an insulator. Dielectric is nothing but the other name of dielectric is called insulator. So let us say this is two parallel plate. This is positive plate. This is a negative plate. Okay. And distance of separation is what? D. And there is dielectric medium, insulating medium. If there is no other medium, we can say there is air medium. Air is also a dielectric medium. Okay. So now let the area of the plate is A. So A is the area of a plate. And Q is charge on the plate. So this is plus Q, this is your minus Q. So what is the surface charge density? We can write surface charge density is nothing but sigma is equal to total charge distributed per unit area, coulomb per meter square. So this is your surface charge density sigma. And you know, if there are two plate, positive and negative plate, inside these two plate there is an electric field developed. So that electric field value is nothing but E naught. So what is E naught? E naught is equal to electric field. E naught is equal to electric field intensity. Assuming there is only AR. Okay, and this E naught is the electric field intensity, which you know sigma by epsilon naught. So you know electric field intensity between positive and negative plate is equal to sigma naught, sigma by epsilon naught. Okay, so now see, due to this electric field, what will happen? The dielectric inside this capacitor will be polarized. So dielectric means what? Dielectric consists of very small dipole, small dipole. Every dipole is nothing but two equal and opposite charges separated by very small distance. So these are the molecule of the dielectric. So when the electric field is developed in between positive to negative plate, what will happen? You know, any charge particle when brought to an electric field, that charge particle will experience a force. So now this is the direction of the electric field. This is negative charge, this is positive charge. And you know, positive charge will move along the direction of electric field and negative charge will move opposite to that of electric field. So now due to this external electric field, the dielectric inside the plates will be polarized and this negative charge particle will move opposite to that of electric field. So that means the negative charge will come here. So this is negative charge of what? Dielectric. And the positive charge will move along the direction of the external pole. This is your positive charge. Okay, this is your positive charge. And this negative charge induced is equal to say Qi. This positive charge induced is equal to Qi. So this Qi is what? This Qi is equal to what? It is the charge. Qi is the charge induced. By which process? By polarization of process. Due to what? Due to external electric field. So what is that external electric field? It is nothing but E naught. Okay. So now see, due to this induced charge, this is positive, this is negative. Due to this, another electric field is developed from positive plate to negative plate. And that electric field is called EI. That electric field is called EI. So what is EI? What is EI? So EI is equal to electric field induced due to which charge? Due to induced charge. Due to induced charge. And definitely the electric field intensity developed due to induced charge is definitely less than that of electric field developed by the main charge plus Q charge. So EI is less than E0. So that implied what is the net electric field intensity developed in this dielectric? So E naught is towards right, EI is towards left, E naught is greater than EI. So net electric field intensity is nothing but E naught minus EI. Okay. And this net electric field intensity is less than E naught. E naught means only due to external charge. This is E naught. So if there is no other medium, then it is E naught. But if there is another medium, there is some induced electric field. So net electric field intensity is now this. And we can write the net electric field intensity is definitely less than E naught. So here the net electric field intensity, which is equal to E naught minus EI, is less than E naught, and that is that net electric field intensity can be written as E naught by K, or K you can write, or E naught by epsilon r. So here, what is epsilon r? Epsilon r is called relative permittivity of medium. And what is K? K is called dielectric constant of dielectric medium. And generally, epsilon r magnitude and K magnitude both are same. So epsilon r is equal to K. So I can write E naught minus Ei is equal to E naught by K or E naught by epsilon r. Okay, and you know the value of epsilon r is always greater than 1 for any other medium, for any medium. And what is the epsilon r value for air? It is 1 for air, or you can say vacuum. So this is the net electric field intensity. So I can write net electric field intensity is nothing but E naught by epsilon r is equal to E naught minus Ei. That implied E naught. What is E naught? E naught is the electric field intensity developed in between this to this. So according to the Gauss law, the net electric field intensity is equal to what? Sigma by A. Sigma by epsilon naught. Sigma by epsilon naught is the electric field intensity in the air. So I can write the net electric field intensity, which is equal to E naught by K is equal to this, and E naught is nothing but sigma by E0. So that implied E0, E naught is equal to sigma by epsilon naught. So here epsilon r is there. So this E naught is nothing but sigma by epsilon naught minus Ei. Ei is equal to what? The induced surface charge density. Sigma is equal to what? The charge density for which charge? Induced charge, that is Qi. So sigma I by epsilon r. Now see, just make it correct here. So E naught is equal to sigma by epsilon naught, here epsilon r. E naught is equal to sigma by epsilon naught minus sigma I is equal to, Ei is equal to sigma I by epsilon naught. So now rearrange this. So go to this. So sigma I by epsilon naught is equal to sigma by epsilon naught minus sigma by epsilon r. Take common sigma by epsilon naught. Here epsilon naught cancel. So you will get sigma I is equal to sigma into 1 minus 1 by epsilon r. So what is sigma I? It is the surface charge density due to induced charge. What is sigma? It is the surface charge density due to main charge. And what is epsilon r? It is the relative permittivity of the medium. Or you can write sigma I is equal to sigma into 1 minus 1 upon K. So if K is expressed in dielectric constant, so this is the value. Okay. So now you see, what is sigma I? It is charge induced per unit area. What is sigma? It is the charge given per unit area. So in terms of this, I can write here, you see, so I can write sigma I is equal to what? Qi by area. Sigma is equal to what? Q by A into 1 minus 1 by K. A cancel. That is induced charge is equal to total charge given into 1 minus 1 by K. So this formula you have to remember for solving the problems. Now see, what is the advantage of dielectric using inside a capacitor? Okay, so why you are using the dielectric inside the capacitor? First of all, without dielectric, what was the electric field intensity? E naught. But using the dielectric, net electric field intensity is equal to what? E naught by K, and K is greater than 1. So that means net electric field intensity decreases by using the dielectric strength. So what is the advantage of net electric field intensity decreases? You know, potential difference is equal to what? V is equal to ED, because you know E is equal to minus dV by dr. The electric field intensity is a negative potential gradient. So if you take the magnitude, dV by dr is equal to E, or dV is equal to E into d. So that is the potential difference. Potential difference without dielectric was E naught d. But using the dielectric, potential difference will be net electric field intensity into d. Net electric field intensity is nothing but E naught by K into d. So here without dielectric it was E naught d. With dielectric it is E naught by K into d. So here But here what happens? The potential difference now decreases. So when there was initially there was only air, at that time potential difference between the two plates was V naught. But when we add some other than air, some extra dielectric medium other than air, the net potential difference decreases. If net potential difference decreases, so that means that capacitor, that arrangement can store more charge. That means its capacity increases. Okay. So question may come. So this is a very important question. Why dielectric is introduced? Why dielectric is introduced in a capacitor? Your answer is to increase the capacity. Why second plate of the earth is always connected to earth? To increase its capacity. So now derive the capacitance of parallel plate capacitor. I have already discussed what is the role of dielectric inside the capacitor. You see, E naught is what? Electric field due to this charge plus Q and minus Q. And what is EI? It is the electric field due to induced charge due to polarization. What is the net electric field intensity? It is E naught minus EI, which is equal to E naught by K. That is, net electric field intensity is equal to E naught by K, which is nothing but E naught minus EI. So this is the net electric field intensity between the two plates. Okay, so that implied the net electric field intensity, which is equal to E naught by K, can be written as, what is E naught? It is sigma upon epsilon naught. And here there is K. And this is nothing but, what is sigma? Sigma is the charge density given on the plate. What is the total charge given? Q. What is the total area? A. So sigma is equal to Q by A into K epsilon naught. This is your net. This is what? Net electric field intensity inside the plate. But we know the electric field intensity and the potential difference relation. So what is potential electric field? Electric field is equal to minus dV by dr. Minus indicates the electric field is along the direction of the loss in potential. But what is the magnitude of the electric field intensity? Magnitude of the electric field intensity is nothing but dV by dr. So here net electric field intensity is how much? Q by A K epsilon naught. And dV by dr. What is the potential difference between these two plates? Potential difference is equal to V. So I am writing V is the potential difference between two plates divided by, what is the distance of separation? D. So I can write this net electric field intensity is equal to V by D. Okay. But we know what is capacitance. Capacitance is nothing but the amount of charge required to raise unit potential difference between two plates. That is C is equal to Q by V. So from this C is equal to Q by V, I got K epsilon naught A by D. And you know K is nothing but your relative permittivity. The value of K and value of relative permittivity both are same. So epsilon naught, epsilon R into A by D is the capacitance formula. So we have to write, so for any medium, that is other than air, so I can write capacitance in any medium is equal to epsilon R epsilon naught A divided by D. And for only air medium, air or vacuum, what is the capacitance? So for air, epsilon R is equal to 1. It is epsilon naught A by D. So we can find the capacitance in any medium divided by capacitance in air medium, keeping all the dimensions same. So we got this divided by this. Just divide this to this. Everything will cancel. So it is epsilon R, or you can say dielectric constant. So this is a short question. So this formula is used to answer very short question. Just like if the capacitance in a glass medium is equal to say 80 farad. Capacitance for same capacitor without glass, that is air capacitance, is equal to say 10 farad. Then what is the dielectric constant of the glass or relative permittivity of the gas? So K of glass is equal to capacitance in glass medium by capacitance in air medium that is 80 divided by 10, so which is equal to 8. So you can answer this. So now we see capacitance depends upon what? So capacitance is directly proportional to the area. You see, in this formula, capacitance is directly proportional to area. Definitely, if area of the plate will increase, the charge possessing capacity of the plate will increase. You will get sufficient area to store more charge. So if area increases, capacitance increases. And we saw here capacitance is inversely proportional to the distance of separation. If that is with decrease in d, capacitance increases. Okay, so why? Anybody who can answer this, just think over this. So by decreasing the distance of separation, capacitance increases. Why? You see, V, what is the relation? E is equal to V by D. E is equal to V by D. So if D decreases, electric field intensity increases. That means that dielectric can withstand maximum stress. That dielectric can withstand maximum stress. That means it can store maximum charge. Or in other way, if D decreases, the potential difference decreases. You see, E is equal to V by D. E is equal to V by D. That implied V is equal to ED. So if D decreases, potential difference decreases, so that more amount of charge can be added without increasing the potential. Okay, if D decreases, potential decreases, then we can add extra charge. So this is. And third factor is, it depends upon the nature of medium, nature of dielectric medium, directly proportional. So if you take a dielectric medium whose dielectric constant is more, then capacitance will be more. So in this way, so this is the formula derivation. It is a probable question for any board exam or any semester exam. So now see, this is the capacitance formula, epsilon naught epsilon r A by D. So from this I can write epsilon naught is equal to C into D by epsilon r into A. So whatever, so the epsilon naught value is equal to this, we have known. And what is the unit of epsilon naught? You see, capacitance unit is farad, D is meter, area is meter square, epsilon r has no unit because it is a relative term. So farad per meter. Or other unit is equal to Coulomb square, Newton inverse, meter minus 2. So now what is the advantage of dielectric medium using the inside the capacitor? So I have already give the reason. By using the dielectric, epsilon r increases. If epsilon r increases, capacitance value increases. So capacitance value increases. And it gives better strength to capacitor. So if you will take two capacitor separated by only air, so it has no, it will not provide the mechanical strength comparing to other medium. Third, it can prevent breakdown of dielectric medium. So in case of air, what is the electric field strength? It is E naught. But using the dielectric, what is the net electric field intensity? E naught by K. So this E naught by K is less than E naught. So that means breakdown strength, that is E naught by K, will be less than that of air only. So that means the stress or electric field in the dielectric is reduced. That means breakdown strength also reduced. Another factor is that this is plus Q charge, this is minus Q charge. So two equal and opposite charge, definitely they will attract each other. So if we introduce the dielectric, so this dielectric can prevent the force of attraction between plus and minus charge, so that plate will not stick with each other. Plate will not come closer to each other. So there is a possibility, because this is positive and this is negative, both will attract each other. So due to dielectric, it will prevent the sticking of the two plates with each other. Now see, suppose this is a capacitor where the dielectric consists of air as well as some other dielectric medium. So that means this capacitor is filled by partially with a dielectric medium with thickness T and relative permittivity epsilon r. And the rest, what is the distance of separation between two plates? D. and here T is the thickness of the dielectric medium. So remaining is what? D minus T. So with this D minus T thickness there is air. And let us say V is the potential difference between two plates. D is the distance of separation between the two plates. So now with what is the potential difference between AM plate and AN plate? So potential difference between AM and AN is nothing but V. So that V can be written as the electric field intensity inside the plate into distance of separation. Remember, this E is uniform electric field because we are assuming the thickness between the two plates is very small comparing to the area of the plate. In that case, we can assume E is constant. So I am writing E is assumed to be constant because the distance of separation is very less than the area of the plate. Okay, so in that case we can say E is constant or uniform. So V is equal to E into D. So now see, so there are two electric fields. So from positive to negative, so it is the electric field developed in the air, and electric field developed in the dielectric medium is say E2. E2. So I can write V is equal to, what is the formula? V is equal to ED. So in the air gap, what is the electric field intensity? E1. What is the distance? That is D minus T. Plus in the dielectric medium, what is the electric field intensity? E2. What is the thickness? T. So this is your V. So that implied. So in the air gap, the electric field intensity E1 is taken to be E0 into D minus T. Plus in the dielectric medium, the electric field intensity is nothing but the net electric field intensity in the dielectric medium we have already discussed. It is E0 by K. So E2 is equal to E0 by K into T. So that implied V is equal to, what is E0? It is the electric field intensity developed in the air. And you know, according to Gauss law, E0 is equal to sigma upon epsilon naught into D minus T plus E0 is equal to sigma by epsilon naught into K. You can write K as well as epsilon r. So I am writing K here. So K into T. So that implied take common. What is the common? Sigma by epsilon naught. Take the common. So it is D minus T plus T by K. T by K. So that implied V is equal to, what is sigma? Sigma is the surface charge density, which is nothing but Q by A. In place of sigma, write down Q by A into epsilon naught into D minus T plus T by K. So that implied we want to find capacitance. Capacitance is nothing but total charge per unit potential difference, that is Q by V is equal to C. So this is Q, this is V. Q by V is equal to what? Just take the mathematical analysis. So epsilon naught A by D minus T plus T by K. Okay. So now you see, I can write capacitance. This is capacitance in which medium? Partial dielectric and partial air. So capacitance is nothing but epsilon naught A by D minus, take common here T. If I'll take common T, it is 1 minus 1 by K. So now this is the capacitance for a capacitor with filled by air partially and dielectric partially. Okay, so here what will happen? You see, instead of dielectric, if I could have taken the total space is filled by air, in that case, what will be the capacitance value? If it is filled by totally air, then capacitance value is nothing but epsilon naught A by D. This is the capacitance of this capacitor when it is filled by air only. But here with air and dielectric, I got epsilon naught A by D minus something. Now we compare this with this. Here epsilon naught A by D, here epsilon naught A by D minus something. That means here denominator is less comparing to this. So if denominator is less, then the value, the fraction will be more. That means capacitance with dielectric is greater than capacitance in air medium. So we proved here also using dielectric capacitance value increases. Okay. Then another very shortcut method of the formula you can remember here. You see this capacitance I can write epsilon naught A by, you see, so d minus t plus t by k. I can write here this is d minus t by 1. I can write d minus t is nothing but d minus t by 1. So this d minus t by 1 plus t by k. What is d minus t? D minus T. So this D minus T is the thickness of air. And what is the relative permittivity of air? 1. And what is T? T is the thickness of the dielectric medium. What is the dielectric constant of that medium? K. So now I am writing one formula, that is general formula, C is equal to epsilon naught A by sum of T by K. So that means if there are two medium, you have to write capacitance is equal to epsilon naught A by T1 by K1 plus T2 by K2. If there are three medium, you can write it plus T3 by K3. So what is T1? T1 is the thickness of one medium. What is K1? K1 is the dielectric constant of that medium. T2, what is T2? T2 is the thickness of the second medium. K2 is the dielectric constant of the second medium. So this is very, very important formula. Now see, this is the capacitance of a composite capacitor. Composite capacitor medium means composite medium. For a composite, not composite capacitor, for capacitor with composite medium. What will the formula of capacitance? You see, capacitance general formula is equal to C is equal to epsilon naught A by sum of T by K. That is equal to epsilon naught A divided by sum of T by K. How many sum will you take? It depends upon number of medium. How many mediums are there? 1, 2, 3, 4. So for first medium, what is the thickness? Thickness is equal to T1 divided by, for first medium, what is the dielectric constant? Epsilon R1 or relative permittivity epsilon R1. For second medium, thickness is T2, relative permittivity is this. For third medium, thickness is T3 divided by epsilon R3 plus rest is air medium. So what is the total distance between the two plates? D. So from D, T1 plus T2 plus T3 are filled by some other medium. Then air thickness is equal to what? Total is D minus T1 plus T2 plus T3 whole divided by its dielectric constant. So what is the dielectric constant of air? It is 1. So in this way, you can find the capacitance of a composite medium. So let us take one example. Example 24.2 of the book, University Physics book. You see, parallel plate separated by 5 mm distance. So this is a two parallel plate. The distance of separation is given 5 millimeter. Immediately convert into SI system 5 into 10 to the minus 3 meter. Filled with vacuum. So here there is vacuum. So in vacuum, what is the relative permittivity? 1 or dielectric constant is 1. So area of the plate is given 2 mm square. Area of the plate is given 2 millimeter square. So 2 millimeter square means, so what is the area? Area is equal to, 1 millimeter. 1 millimeter is equal to what? 10 to the power minus 3 meter. So 1 millimeter square is equal to 10 to the power minus 6 meter square. So 2 into 10 to the power minus 6 meter square. Area is given. So, and a 10 kV is applied across the capacitor. So what is the potential difference? 10 kV. kV means 10,000 volt. So first you have to find what is the capacitance. So capacitance formula, this is vacuum. So it is epsilon naught A by D. Epsilon naught A by D. So epsilon naught. Okay, in the problem, yes. It is not given millimeter square. In the problem, it is given 2 meter square. So 2 meter square. not millimeter square. So in that problem it is given area is equal to 2 meter square. So what is the value of epsilon naught? 8.854 10 to the power minus 12. This is epsilon naught into area 2 divided by distance of separation 5 millimeter, that is 5 into this. So if you will calculate, you will get 3.54 into 10 to the power minus 9 farad. So that is equal to 3.54 10 to the power minus 9 means nanofarad. This is the first answer. Come to second bit. Charge on each plate. Charge on each plate. Q is equal to what? CV. So C is equal to 3.54 10 to the power minus 9 into voltage. What is the potential difference? 10,000. So if you will multiply, you will get 35.4 into 10 to the power minus 6, which is equal to 30.54 microcoulomb. This is the charge. Okay. Next, third bit. What is the electric field between the two plates? We know electric field intensity is equal to what? V by D. So V is equal to 10,000. Distance of separation is equal to 5 into 10 to the power minus 3. So if you will divide, you will get 2 into 10 to the power 6 volt per meter. Or another process is that E is equal to sigma by epsilon naught. Sigma is nothing but Q by area. So Q by epsilon naught A. Q is already given. What is the charge? 35.4 nanocoulomb, micro, 10 to the power minus 6. Divided by epsilon naught, that is 8.854, 10 to the power minus 12. Area is equal to 2. So definitely you will get same result, that is 2 into 10 to the power 6 volt per meter. So with this I am concluding the today's class. So